Let's talk about triangles. Triangles are three-sided shape with three interior angles. 1, 2, 3. So the angle facing this side, let's use one stripe. The angle facing this side, let's call it this. While this third side, let's use 3 stripes. So the longer the A side, the more the angle facing it. So for example, if I have a triangle this way, by merely looking, this is the longest side, right? So definitely this will be the biggest angle. This is the smallest side, definitely this will be the what? Smallest angle. So we'll classify triangles into 2 for this lecture. So the first one is a right angle triangle. Again. So for a right angle triangle, it is a triangle whereby one of its interior angle is right 90 degrees. Since total angle in a triangle is 180, if I have, let's say, A, B, C, if you have to add A plus B plus C, you must always get what? Sum of angles in a triangle sum up to what? 180 degrees. So if this angle is 90, it means this remaining 2, when you add it, we must get what? 90. If I add this angle and this angle, we must get 90. Let's call this angle theta. This one alpha. Theta plus alpha must give us what? 90 degrees. So these two angles are what? They are called complementary angles. Complementary angles. Again. So what are complementary angles? Complementary angles are angles that are sum up to 90. Show your email. Alright. This side facing this 90 degree will be the longest. Definitely. Why? Because these two angles must be what? 90 altogether. They will share it. It needs to be 90. So this longest side is called the hypotenuse. Now we have two angles here. If you are considering this angle, what faces this angle, the side that faces this angle you are considering, is called the opposite. While the third side is called the adjacent. And I believe you all know Pythagoras theorem. He said the square of the hypotenuse equals to the sum of the square of what? The opposite and the adjacent. You know this, right? Then you have to know the Trig.Ratios too. What are the Trig.Ratios? We have the common ones are what? Are 3. We have the sine of the angle we are considering, the cosine of the angle we are considering, and the what? The tangent of the angle you are considering. Because when you are in junior secondary school, you will be taught so again. Once again. So means what? Sine equals to opposite over hypotenuse. What's the opposite? Let's call this opposite A. Let's call this adjacent B. This hypotenuse C. So in this triangle, what is sine theta? Opposite over hypotenuse, and that's what? A over C. Shebi now? What is cos? Adjacent over hypotenuse. What's the adjacent here? B over. What's tan? Toa. Opposite over adjacent. What is the opposite here? A. Adjacent B. That is what? A over B. We also have what we call cosec theta. Cosec theta is actually the inverse of sine. It is what? 1 over sine theta. We have the what? Sec theta. What is sec theta? Inverse of cos. 1 over cos. And we have what? Cot theta, which is what? 1 over tan theta. Now, if we divide A over C by B over C, if we do A over C divided by B over C, instead of writing A over B times C over B. Yeah, am I correct? Yes. Are you sure? Yes. No, I don't think so. A over C, B over C. Oh, it's A over C, thank you. It's A over C here. Here it's A over C. C cancels, that's what? A over B. What is A over B? Tan. Meaning if we divide sine by cos, we get tan. So from here it means what? Tan theta equals to sine theta over. This is what? Pythagoras theorem. These are the 6 what? Trig ratio. Then the relationship between sine and cos is that what? Tan theta equals to sine theta over what? Cos theta. You should know this too. Since cot is 1 over tan, what will be cos theta in terms of sine and cos? That will be cos theta over what? Sine theta. You have to first know this. Now, one of the applications of this trig, particularly this right angle triangle, is the concept of what? Angle of elevation and what? Depression. But we'll move here. Let's do some kind of calculation here. Let's suppose you are given this triangle. G, number one. Let's start with the simplest question. This side is given as x, we don't know it. This side is given as 5 centimeter. Here, 12 centimeter. Class, what will be the value of x? What are you going to apply? If you have two sides of a right angle triangle, to get the top side, it's very simple. You apply what? What does it state? The square of the hypotenuse. Opposite square plus. So the first is to identify the what? Hypotenuse. Where is the hypotenuse here? So I'll write the x for. So I'll say what? S squared equals to 12 squared plus what? 5 squared. What was 12 squared? Again. 5 squared. Adam. Square root both sides. Square root of x squared equals to square root of what? Cancel. From here, what's the value of x? 13. So for a rectangle triangle, if I have 5 as a side, 12 as a side, the third must be what? So these are what we call Pythagorean's what? Triple. 3 numbers that will base Pythagoras what? Theorem. Let's take it a bit harder, but it's not really hard. Let's suppose we have something like this. This one is x, this one is 3, and this one is 5. To get x, same thing. We are going to apply what? And the first is to identify the what? What is the hypotenuse? So I'll write what? 5 squared equals to plus what? What is 5 squared? 3 squared plus what? So bring this 9 here. 25 minus 9 equals to, subtract this, equals to get x, you square root both sides. Square root of 16 equals to square root of, what was 16? Plus or minus 4. But we are dealing with sides, so it's going to be positive. So therefore, x equals to what? 4 units. Is that clear? If you are given two sides, you can get the third side if it's a rectangle triangle. Very simple. Now, question 3. If sine theta equals to 3 over 5, find cos theta plus cosec theta over 1 minus cot theta. Let's see 1 plus cot theta. If you are given a particular trig ratio, like here, we are given sine. We know from SOHCAHTOA that sine is opposite over what? Hypotenuse. So if this is theta, then the opposite, according to this, is 3. And the hypotenuse is what? Is 5. We can get this adjacent by applying Pythagoras theorem, which we've done here already. And this side is what? 4. So what is cos from car? Adjacent over hypotenuse. This is the opposite. This is the adjacent. This is the what? Hypotenuse. So from here, it means cos theta is adjacent 4 over hypotenuse 5. Cosec is actually the inverse of sine. Inverse of sine. So sine is 3 over 5, then inverse of sine is what? 5 over 3 divided by 1 plus. Cot is inverse of tan. Tan itself is opposite over adjacent 3 over 4. This is tan. Cot is the inverse of tan, which is going to be what? 4 over 3. Then from here, if you sum the bottom, you get the final answer as 1 number 2 over 35. You can try that yourself. Now look at this question 4. If sine 2 alpha plus 5 degrees equals to cos 3 alpha minus 15 degrees, find the value of alpha. Sine and cos are equated for a certain angle. Recall, when I started this lecture, for a right angle triangle, if this side is theta, let's call this one alpha, or let me call this one beta, or let me call it 5, for example. So this side is the opposite, let's call it A. This is the hypotenuse, let's call it C. The adjacent, let's call it B. So if we are considering this angle, then sine theta equals to this will be opposite this time around. Opposite over hypotenuse, A over C. But if I'm considering the second angle here, this alpha. Or first, let's do cos also. Cos theta will be the adjacent to hypotenuse. And what's the adjacent? B over what? C. But if you are not considering alpha, if you are considering second angle phi, so what will be the value of sin phi? Sin phi in this case, B will now be the opposite. This hypotenuse is always fixed. If we are not considering this angle, B is no more the opposite. B is now the opposite. So in this case, sin phi is going to be what? Opposite over B over C. Then what happens to this? What we cos phi adjacent over what? That's A over C. When you now observe, look at this. This is A over C, A over C. Technically from here it means what? Sin theta equals to what? Cos phi. Sin and cos will be equal for a certain angle if theta and phi are complementary. Because in this diagram, these two angles, if we add them, alpha, theta plus alpha for plus phi, we must get what? Since total angle in the triangle is 180. Think about get 90, many of us will be 90 also. So these two angles are complementary. So if this angle and this angle is complementary, if the two angles are complementary rather, sin theta will equal to cos alpha. Now come back to this question. Sin something equals cos something. We are going to assume that these two angles are complementary. So meaning if we add this angle, which is what? 2 alpha plus 5 plus 3 alpha minus 15, the answer must equal what? 90. That will be the assumption. 2 alpha plus 3 alpha gives what? 5 minus 15 equals to what? So take this one there. 5 alpha equals to 90 minus 10. So plus 10, thank you. 5 alpha equals to, you have answer by 5? 20. So alpha equals to 20. Let's test it. Let's put 20 here. 2 times 20. 40 plus 5. So sine 45 degrees. Let's see if it's equals to 3 times 20. 60 minus 15. So sine 45 cos 45 must equal. You can press in your calculator. As well as this angle, when you add them, if the answer is 90, they will have the same value. Now give me two angles that will give me 90 degrees. Let's use 90 and 0. Sin 90 will be equal to cos 0. Sin 90 is 1, cos 0 is 1. Sin 60 must be equal to cos what? 30. Sin 15 must be equal to cos 75. Sin 80 must be equal to cos what? 10 degrees. When you add this angle and your answer is 90, the sine and the cos of those angles have to be what? Equal. Is that understood? Same thing also works for tan and cot. If we do tan theta for this triangle, what's tan theta? Opposite over what? If I do tan phi, this will be the opposite now, B over A. What you notice, they are reciprocal of each other. So I can say from here, tan theta equals to 1 over tan phi. Yes. But if I do 1 over tan phi here, it will be A over B. And what was 1 over tan? Cot. So it means tan theta equals to what? Cot phi. If theta and phi are complementary. So tan goes with cot. Sine goes with what? Cos. Is that understood? Now look at this question 5. Unlike the previous question we've been solving, we are given two sides. We are looking for the third side. In this case, we are given only one side. In a right angle triangle, if one side is given, we cannot get the other two sides unless you are given one of the interior angles, either this or this. So if you are given two sides, you can get third side using Pythagoras theorem. But if you have two unknown sides, you must have a known side and one angle that is known. So here, the known side given is the opposite to this angle. So opposite is known. So to get x first, let's move on to get x first. This opposite, what is this? First is to identify that this y is what? Hypotenuse. This is the what? Opposite. And this is what? The adjacent. So opposite adjacent is what? Cos. So it means in this case, do cos 60 equals to, what is the opposite? 12. What is the adjacent? X. What is cos 60? 0.5. Sorry, is it tan? Yes. Opposite adjacent, thank you for that. That's tan 60. And what's tan 60? Root 3 equals to 12 over x. From here we can multiply, or you can swap it directly. It means x equals to what? 12 over root 3. It allows a math. If a equals to b over c, you can say c equals to what? B over a. It's equal. It can work that way. Then from here, this is value of our x. But in mathematics, it is not allowed for you to leave a rational number as the denominator. So when you have it like this, you do what? We rationalize. Multiply by what? The conjugate of the denominator, which is root 3. So this is under solved. 12 times root 3, 12 root 3. Root 3 times root 3, 3. 3 in 12, 4. So what's x? 4 root 3 centimeters. Now that we now know x, we know this side. Two sides are now known. To get y, you can now apply what? Pythagoras theorem. But don't waste your time. Use trig ratio. Why? Because from here, y is the what? Hypotenuse. So I know the opposite. I want to get hypotenuse. Opposite hypotenuse is what? So that's sine. So sine 60 is the what's the opposite? 12. Hypotenuse y. What is sine 60? Root 3 over 2. In this jam, you have to use special angles. So we have 5 special angles. Or is it 5 or 6? 0, 90, 30, 60, 45. For those 5 angles, you must know the value of sine, cos, and tan. Perhaps I'll give you 4 to x plus n. 12 over what? Y. So to get y, do what? Cross multiply. So y root 3 equals to 2 times 12. To get y, we divide both sides by what? Root 3 over root 3 over root 3. So y equals to 24 over. Same thing here. We can only answer this way. We have to rationalize, right? So I multiply by what? Root 3 over root 3. So here I have y equals to 24 root 3 over 3. 3 24. That's 8 root 3. So this is our x and this is our y. This one is still direct. Let's make the question more difficult for y standard. Now on the board, we have 2 questions. 6 and 7. This question 6 is actually from y 2016 number 16. So you are told to look for angle UTW. UTW, the whole of this angle. Now, when we check this triangle as a whole, it is not a right angle triangle. It is not, because it's 90 degrees. So since we are solving right angle triangle, so we need to look into it as a right angle triangle. This side, UTX, is a right angle triangle on its own. If this angle is 90, definitely this is also 90. So it means this angle TSW is also what? A right angle triangle. Let's separate them out. So this is given as 1, right? Root 3. We are looking for the whole of this angle. Let's call this A, let's call this B. So we are actually looking for what? A plus B. The A belongs to this. This is 1 root 3, 90. For this second part, let's make it this way. So this is root 3. This side is common, TX is common. So if this side is root 3, this side is also what? Root 3. Then we are looking for what? B. Now here, this one is the opposite, right? This root 3 is what? Is what? Adjacent. So it means tan A. What is in tan? Opposite adjacent equals to 1 over root 3. Then for this case, tan B, it's still tan because it's opposite adjacent. What's tan B? Root 3 over what? Root 3. Which implies that tan B equals to what? 1. This is why you have to know special angles. Tan what will give us 1 over root 3? It's actually tan 30. Tan 30 degrees will give you 1 over root 3. So it means our A is what? 30 degrees. Also, tan what will give us 1? It is tan 45 degrees that will give us what? 1. So it means B equals to what? So total angle here, which is A plus B, that's angle UTW equals to A plus what value of A? What is B? Final answer is what? 75 degrees. Now this question number 7 is y 27 over 32. So we are told to look for angle X. Now if you check, this angle X belongs to triangle PSQ, which is not a right angle triangle. So the best is for us to take out this rectangle triangle first. Here we have two rectangle triangles. We have the bigger one, PSR itself. If you consider PSR, we can get this whole angle. For PSR, let's call it whole angle, let's call it theta. So for this whole angle, the whole side, PR is one facing it. So the angle facing theta is actually what? 10. 4 plus 6, 10. So this is opposite, this is adjacent. So opposite adjacent is what? Tan. So we can get theta there. Tan theta is, what's the opposite? That's 4 plus 6, 10. What's the adjacent? 12. To get theta, you can use a calculator. So theta here will just be what? Tan inverse of 10 over 12. We can get one of theta. Why? We can also get this small angle here. Let's call this small angle y. So if we consider this angle y, the side facing y is actually what? QR, which is 6. So this QR, which is 6, is the opposite. This side is the adjacent. So if we do tan y, so tan y goes to opposite, which is 6, over adjacent, which is 12. From here we can get y to be what? Tan inverse of 6 over 12. So from here, definitely x plus y must give us theta. X plus y must give us theta. Our aim is to know the value of x. So x equals to theta plus y. So from a calculator, we can get the value of theta, put it here. From a calculator, get the value of y here, put it there, then get your answer. So press. What is tan inverse of 10 over 12? Theta is 39.805. That's 81. What is this one for this? That should be 30. No? Where press it? 30 what? 26.56. So subtract, get the final answer. Okay, 57. Final answer is what? 13.24. Now, this question 5 is from WAEC 2012, number 18. So, you are told to look for the value of x, PS. You can try this yourself. It's very simple. Look at this. Don't disturb yourself. You are looking for the value of x. Let's consider this whole triangle. PQR. PQR. So, this 30 is the angle facing this side. So this is the opposite, and this is what? Adjacent. So tan 30 equals to, what is the opposite? What is the adjacent? This plus this. Tan 30 is what? 1 over root 3 equals to 10 over x plus 8. Cross multiply. So when you cross multiply, x plus 8 times 1 is still what? X plus 8. This times this, 10 root 3. So x equals to 10 root 3 minus 8 meters. So in decimal, you can press calculator. 9.32 meters. Now for the special angles I promised. So we have to know for 0, for 90, for 30, for 60, and for 45 degrees. Now for all these angles, you have to know the value of the sine, cos, and the tangent of all the angles. And there's a way you can prove all by geometry. 0 and 90 are complementary. So it means sine 0 cos 90 must be equal. Sine 0 is 0, cos 90 is 0. Sine 30 is half, cos 60 is half. Sine 45 is root 2 over 2. Cos 45 is also what? Root 2 over 2. Because 45 is 90. Same thing, sine 90 is 1, cos 0 is 1. Because 0 plus 90 is 90. Same way, sine 60 is root 3 over 2. Cos 30 is what? Root 3 over 2. Cos 30 and 60 are also complementary. Tan is sine over cos. 0 over 1, 0. 1 by 0, undefined. Half over this, you have 1 over root 3, which is root 3 over 3. This will give us what? Root 3 over 1. And this gives us what? 1. So these are the special angles. You must know them by heart. From 0, 90, 30, 60, 45, you should know the sine, cos, and tan for all. I believe you now understand the use of right angle triangles. So in our next class, we move to application. That is word problem leading to right angle triangle. Majorly the concept of angle of elevation and depression. We all know right angle triangles to be triangles whereby one of the interior angles is 90 degrees. And the longest side facing this angle is called the hypotenuse. So we already talk about the trig ratios, the 6 trig ratios: sine, cosine, tangent, cosecant, secant, and cotangent. Also, we'll look into Pythagoras theorem. So today we are moving to one of the applications, which is angle of elevation and depression. Now suppose this is a tree standing firm on this horizontal ground, and we have a man standing right here. So let's say this is a man's face facing this side. So this is the level of the man's eyesight. If we have a bird in this tree, let's suppose we have a bird in the tree at this point. So for this man to be able to view this bird, he needs to elevate his sight. From this level, he will elevate his sight. So this is the line joining the observer and the object. So the angle joining the eyesight of the observer and the object when the gaze moves up is what we call angle of elevation. Let's call this angle here alpha. So if the man is to look at something beneath the tree, so the man has to lower its gaze by bringing the eyesight down. So in this case, the angle between the horizontal level and the line joining the observer and the object is called the angle of depression. Let's call it beta here. Now here we can be asked to get different things. For example, what is the height of the tree from this point down here? First you have to realize is this angle here is 90 degrees. This angle here also is 90 degrees. If this angle here is beta, this angle is also beta because they are alternate to each other. Alternate angles are equal. So from here, we can bring out two right angle triangles. So this is the first one. This 90 degrees. This is the angle of elevation. Then we have this second one. So this is better angle of depression. And this is the man standing. So this is the height of the man. Let's call it H. So this is the height of the man standing. If from here to here is H, from here to here definitely is also H. If the height of the tree from this point down is big H, so if from here to here is big H and from here to here is small h, definitely from here to here will be what? Big H minus small h. So even for this triangle, this is what? Big H minus small h. This is small h. The distance of the man, between the man and the tree is fixed. Let's call it D. Let's call distance D. So if from here to here is D, definitely from this point to this point is also D. Then if this is D, from here to here is also D. So for example, let's suppose you are given the angle of elevation alpha and the angle of depression beta. You might be told to look for the height of the man and the height of the tree. Then from here, this is the opposite, this is the adjacent. So from here, if we do tan alpha, the opposite is what? H minus H over what? D. And from here, same thing, this is the opposite, this is what? Adjacent. So if we do tan beta, what's the opposite? Small h over D. So if we are given the angle of elevation and depression, and the distance between the tree and the man, D, we can get the value of what? H and big H. Because if we know this, and we know this, we can get H. If we know H, we can put it here and get big H. So it's either you are given the two angles and the distance, and we total for this big H and small h, or you won't be given the distance, but you'll be given the height of the tree or the man. So we are just working around this. And most times we use mainly the tangent among the trig ratio, because most times we talk about the opposite, which is the height, and the distance adjacent, which is the to understand this better, we need to solve questions. So let's take some why questions. The first question here is from 2009, question 7. A woman looking out from the window of a building at a height of 30 meters observed that the angle of depression of the top of a flagpole was 44 degrees. If the foot of the pole is 25 meters from the foot of the building, find to the nearest whole number the 1 angle of depression of the foot of the pole from the woman, height of the pole. Very simple. You have to first show this in the diagram. So they said a woman looking out from the window of a building. So let's say this is a building. We're going to sketch a beautiful building. Let's say this is a building. So what happens? We are told that the building, okay, at a height of 30 meters. Let's from here, from 0, let's say this from here to here is 30 meters. From this height, so ordinarily from this height, this will be the line of eyesight of the woman. Observe that the angle of depression, she's looking down to here, to the top of the flagpole. So let's say this is a flagpole. This is the top of the flagpole. Let's call it T. She observed the top of the flagpole. So this is the observer, this is the object. So this is the angle of depression, the angle between this line and the horizontal. Given as what? 44 degrees. Okay? If the foot of the pole is 25 meters from the foot of the building, so it means from here to here is 25 meters. Find to the nearest whole number the angle of depression of the foot of the pole. This is the pole, the foot of the pole from the woman. It means from this woman, if the woman is to look down to the foot here, what is the angle of depression? You are looking for the whose pole angle from here to here, which is the same as from here to this place. Don't mind how big this is. This angle and this angle are equal because they are alternate. So that is what we are looking for first. The first thing is for you to know that this angle and this angle they are equal, and this is what we are looking for. So let's call this angle alpha. This is definitely 90 degrees. So when you observe, this is opposite adjacent. So we just use what? Tan alpha. So tan alpha is what's the opposite? 30 over 25. From here, alpha is the tan inverse of 30 over 25. With the help of your calculator, we can get alpha to be to the nearest whole number. The angle of depression is going to be 50 degrees. Okay, second part. The height of the pole. This is the height of the pole. Let's call it h. First thing I will do is I will trace this one here. Why am I doing that? Because this 44, we cannot relate this 44 to any angle in this shape. But by doing this, if this angle is 44, definitely this angle is also 44. Because they are alternate. So this angle is also 44 degrees. If from here to here is h, definitely from here to here is also h. Now, if from here to here is 30, and from here to here is h, what will be from here to this point? Then you 30 minus h. This is also 90 degrees. So we have another right angle triangle. So let's draw out the right angle triangle. We have this, and we have this. 30 minus h, 44 degrees. If from here to here is 25, what will be from here to here? 25. So given this angle, this is the opposite, this is the adjacent. So we are going to use what? What's the opposite? Over. So multiply, we are going to have what? Equals 25. With the help of your calculator, what is 25 times 44? 24.14. From here to get h, let's move this h minus to this side. So 30, this positive number, when it comes here, becomes minus. Equals to h. From here, what's h? 5.86. And the next row number, that is 6 meters. And that is the end. This Y question is from 2012, number 8, theory. A point H is 20 meters away from the foot of a tower on the same horizontal ground. So meaning we have an horizontal ground, and on this ground we have a tower, and a point H is 20 meters away from the foot. This is the foot of the tower. On the same horizontal level or ground, we have a point H. Let's use our point H. Let's use the foot of the tower. What happened? The angle of elevation of the point P on the tower. So on this tower, we have a point P. We don't know. Let's just pick a point. Let's see this point P on the tower. Point P. So from this point H, the angle of elevation of the point P on the top and the top T. So this is the top of the tower. And the top T, no, this H is our reference point. And the top T are 30 and 50 respectively. 30 and 50 respectively. So it means this angle here is 30 degrees. And all of this angle here is what? 50 degrees. Find to 3SF. Line segment PT. Want to get PT from here to here. Let's call it PT. Then HT. HT. After getting PT, we are looking for HT from here to here. HT. Before the third one, let's see how we can get our PT. First, you have to realize that this angle is 90 degrees. Vertical, horizontal, 90 degrees. And we are given distance HF, 20 meters away. So from here to here is 20 meters. Now from here we have two rectangle triangles. Let's bring them out. First, we have this small one. First, we don't know from here to here. Let's call this angle PF. Let's call it X. So if we bring out this small triangle PHF, this P, this HF, this point P. So we call this X. This is 90 degrees. This is 20. This is 30. We know we can get value of X directly. Now, if you consider this big triangle TFH, these are HT. From here to here, it's actually PT plus X. Right? PT plus X. This is also 90 degrees. And they share this base, so this is also 20 meters. And the one of this angle is what? 50 degrees. Now the first thing you are told to look for is PT. From this triangle, I told you, if you have a right angle triangle, and one side is given, and one angle is given, we can get the other two sides. So, but if we consider this opposite and adjacent, we have to get PT plus X. But we cannot get PT until we know the value of X. So from here, let's get the value of X first. Let's get the value of X first. From here, the opposite is X, the adjacent is 20, and the angle is 30. So from there, it means tan 30 equals to, what is the opposite? x over 20 over 1. Multiply from here, x equals to 20 tan 30. So what's the value of x in decimal? 11.547. Now, let's come back to the second triangle. This is the opposite. So when you use tan 50, what is the opposite? PT plus x over what is the adjacent? 20. Cross multiply. It means PT plus x equals to 20 tan 50. So PT plus what is x? 11.547 equals to what is 20 tan 50? 23.835. So to get PT equals to 23.835 minus 11.547. What was the answer? 12.288 meters to 3 SF. 1, 2, 3. So that's 12.3 meters. And that is PT. Next part of the question, we are told to look for HT. HT. HT belongs to this second triangle. So we already know the value of, see, we already know 20 here, right? So we can get HT. So this is the hypotenuse, and we have the adjacent. Adjacent hypotenuse. So we can use what? Car, that's cos. Cos 50 is what? Adjacent over hypotenuse, HT. You can switch this directly. From here, it means HT equals to 20 over cos 50. From here, what will the value of HT? 31.114, approximately what? 31.1 meters to 3 significant figure as asked in the question. That is very direct. The third part of the question says, find the position of H if the angle of depression of H from the tower is to be 40. Well, is it from the top of the tower? Yes. Let's suppose it's from the top. Now, for this angle to be 40, initially the angle was 50. 40 is more than 30, but not up to 50. Now, from this top, this angle from the top was 50. For the angle to be 40, this H has to move further away. Because the closer H to the foot, the bigger the angle of depression. So this is the top of the tower. So for the angle of depression to be 40, what must be the position of H? Let's suppose H is now here. This angle here is 40. If this angle is 40, look at this. Go here and come. This angle too must be what? The height of the tower is fixed, it can't change. So from here we have a giant triangle. Look at this, this, and this. So from here to here is the opposite to this 40. While from here to here is the new position. So if we get the value, let's call from here to here. Let's call it y. So y is the position of H from the foot of the tower. Let's suppose after solving our y is let's say 50. It means H is 50 meters away from the what? Foot of the tower. So we want to get the value of y. So what is the opposite? Using tan y from here. Sorry, tan 40. What is the opposite? The whole of this. PT plus x. Which we've already got to it here. PT plus x. If we have our PT. From here, look at this from here. PT plus x is what? 20 times 50 directly. And what is 20 times 50? 23.83. We have it here already. So this answer here actually represents what? PT plus x. So what's our PT plus x? Everything here? 23.835 over new position y. From here, y equals to 23.835 divided by tan 40. So, by the use of a calculator, we can get the value of y to be 28.4 meters. So the position of H when the angle of depression on the top is 40 is 28.4 meters. Number 3, the feet of two vertical poles 3 meters and 7 meters are in line with a point P on the ground. So on the ground we have two poles and point P. What's the arrangement? Let's see. The smaller pole is pinned between the taller and point P. It means we have to draw the taller one first. Taller pole, point P, shorter pole. The top of the taller pole, shorter pole, the top of the taller pole. This is point P. So we are not told, and at a distance of 20 meters from P. It means the smaller pole, like the smaller pole is in between. Oh, sorry, it's opposite, not this way. We are told that the smaller pole is between the taller pole and point P. So the smaller pole is somewhere here. And at a distance of 20 meters from P, from here to here, is given to be what? 20 meters. Are you with me? Yes. The angle of elevation of top T of the taller pole, is that elevation? Is it meant to be elevation? The angle of elevation of top T of the, okay, from point R. So R is the top of the smaller pole. T is the what? Top of the taller pole. So from R to T is going to be elevation. And we are told that the angle of elevation is what? 30 degrees. I want the angle to be within this shape. So from here I can draw this and slot in 30 here. We are told that the height of this one is 7 meters. And this is what? 3 meters. So if from here to here is 3 meters, it means from here to here is also what? Then the remaining part is going to be what? Because everything is 7. Find RT. RT. It is very easy for us to get this RT. Why? Because we already know this side. This is 90 degrees. We have one angle. If one side and one angle is known, we can get the other two sides. So from here, this is opposite hypotenuse. So we are using what? Sine. So sine 30 equals, what's the opposite? 4 over hypotenuse, RT. From here it means RT, we swap. RT equals to 4 over sine 30. So from here RT is definitely 8 meters. That is the first thing we are told to look for. Secondly, the distance of the foot of the taller pole from P. Distance of the foot of the taller pole from P. We want to get from here to here. Here to here. We already know this one, so we have to get this. If you know the value of x, for the second part, the distance we are told to look for is actually x plus 20. This is the taller pole, this is point P. Distance, x plus 20. Now, if from here to here is x, from here to here is also x. RT is already, it's got to be 8. We can actually use Pythagoras theorem here. Or we can see apply Trig.Ratio. This is opposite, we can call this the adjacent. So in this case, we can use tan. Tan 30 is the opposite 4 over adjacent. From here, it means x equals to 4 over tan 30. From here, x equals to the short form 4 root 3 meters. Which you can write in decimal as what? 6.928 meters. So the distance we are looking for is X plus 20. What is X? 6.928 plus 20. And that is what? 6.9 meters. Right. The third question. The angle of elevation of T from P. From P, we want to get the angle of elevation. So from P to T, it's going to be elevation. So we want to get this angle. Let's call it alpha. It's easy for us to get. Why? Because the whole of this is the opposite to this alpha, which is 7. This is the adjacent, which we have got to be 26.928. So from here, if we use tan alpha, the opposite is the whole of this, 7. The adjacent from here to here is 26.928. So in decimal place, what is this fraction in decimal? Tan. So from here, the value of alpha is tan inverse of 0.2600, and alpha equals to
14.571.
14.571, approximately 14.57 degrees. A boy stands at a point M on the same horizontal level as the foot of a vertical building. So let's say this is the horizontal level and this is the building. This is the boy. The boy stands at a point M on the same horizontal level as the foot T of a vertical building. He observes an object on the top P. So this is top P of the building at an angle of elevation of 66 degrees. So let's say this is the boy's eyesight. This is the level of the boy's eyesight. He observes this top to be at an elevation of 66 degrees. He moves directly backwards. So what was at M before, they moved to a point C and observe the same object at the top. Observe the same object at the top. So let's see this point C. Observe the same object here at the top T. At an angle of elevation of 53, the angle has dropped to 53. If MT is 50, MT from here to here is 50, meaning from here to here is also 50. Find the height of the building. We want to get the height of the building. But there's a problem here. We don't know the height of the boy. If the height of the boy is h, it means from here to here will be h. The height of the building is from P to T. But we don't know this side. So let's call this side, let's say x. So the height of the building is actually x plus the height of the boy. But the most important thing is the right angle triangles. Now let's bring out this right angle triangle. This first one. From P to this point to this point. So we have this. This is 50 meters. From here to here is 50. This angle here is what? 66. This is x. You can actually get the value of x. Then, how can we get x? Opposite adjacent. So tan 66 degrees equals to x over 50. Right? Then from here we can get x to be 50 tan 66. So the value of x is 112.3018 meters. The second part of the question says we should get MC. MC is from here to here. let's call MC y. So from here to here is also y. From here to here is 50. So we bring out this triangle. We have this. This is 90. This is x. If my is 50 and this is y, everything here is 50 plus y. The angle here is given to be 53. So opposite adjacent. So that's tan 53, which is what? X over 50 plus y. In decimal, what is tan 53?
1.327.
You can switch this way. X is 112.30 and tan 53 is 1.3. From here, 50 plus y equals to, let's divide. Then from here, y becomes 84.6269 minus 50. So from here, y becomes
84.6.
So therefore, our MC, the MC you are looking for is actually 34.63 meters. Now, let's go back to the first part. We are told to look for the height of the building. The height of the building is from here to here. We already got the height of the building above the head of the boy. And if we know the height of the boy, we can get the height of the building. The correct height of the building, let's call it big H, is H plus X. We know X, but we are not given H. But the question is, can we get the value of H? If we can, fine. But if you observe, this H did not belong to any triangle. It doesn't belong to any triangle. Unless you want to join this point to this point. And if we join this point to this point, we can get the whole of this. Since we know this side, provided that we know this angle. So the question is, can we get this angle? Can we get this angle? Is the problem. So since we can't get this angle, because the whole of this side is not known. Sorry, yeah, we can't get this angle, we are not given. There's no how we can get outside this box. There's no how we can get this. So apparently, and this line is not parallel to any line. So apparently, we assume that the height of the building we are to get is above the eyesight of the boy. Or perhaps the boy is lying down straight on the floor. If the boy is lying down straight on the floor, then it means all this portion will disappear. And this X will just be the height of the building. But realistically, we need to be given the height of the boy or something to get it. So we assume this is the final answer. For this question, reference to WAEC 2024 number 4. The diagram shows a tower TR. So here we have a tower TR from this point to this point. At O, and an observer at O is O. OR is 84, and the angle of elevation of the top T from O is 57. So the question is, where are we going to put the angle of elevation? Is the angle between this line and the horizontal. Always reference to the horizontal. So this is angle of elevation. It's not drawing diagram, but you should know you should draw it. Okay, let's draw another diagram here. So this is R O T 90 angle of elevation, which is 57 degrees. First question, calculate the height of the tower. This was given, or this is given to be 84 meters. So we are looking for the height of the tower, TR. Let's call it H. So let's call this H. The opposite is H, and this is the adjacent. So we are using tan 57, which is the opposite over the adjacent from where h is 84, tan 57, which is 129.35 meters.
129.
The second part, the observer at O moved away from the tower. This is the tower, this is the observer. Moved away from the tower until the angle of elevation is 49. How far the observer moved backward. So let's say this is the horizontal level. The observer moved from this point, let's say to this point. Let's call this point P. So it has moved a distance, let's call it D. From here to here is D. So the angle of elevation of the top becomes 49. So how far has he moved? So here we have a bigger right angle triangle. This is P, this is R, this is T. And our H is got to, we've already got H 129.35. This is 90 degrees. So this is the new angle of elevation 49. The distance RP is obviously 84 plus D. The whole of this. So opposite adjacent, that is tan. So we say tan 49 is the opposite 129.35 over the adjacent 84 plus D. We can switch, bring this tan below here and throw down there. So 84 plus D equals to 129.35 over tan 49. So 84 plus D. So let's divide 129.35 by tan 49.
112.44.
From there, D equals to 112.44 minus 84. So D equals to
28.44.
note, we didn't declare the value of D or what this stands for initially. So at the end, we have to declare. So therefore, the observer moved a distance of 28.44 meters backward.